It was designed to end the world. Now we are going to end it. Resting in the concrete embrace of Dry Dock 6 at the Puget Sound Naval Shipyard lies 18,000 tons of silent lethality. This is not just a ship, it is a predator of the deep, a nuclear-powered fortress forged from HY-80 steel, an alloy so incredibly dense and resilient that for decades, its chemical composition was a classified state secret. This steel was engineered to withstand the crushing pressure of the abyssal plain and the shockwaves of depth charges. But today, it faces a force it cannot resist, the 50,000-degree fury of the ESAB Super X plasma cutter. This is the only facility in the United States authorized to butcher these radioactive giants. The process is surgical, brutal, and absolutely unforgiving. There is no room for error when dismembering a vessel that once carried enough thermonuclear firepower to level a continent. We are witnessing the first incision. The plasma torch, guided by precision computers, strikes the hull with the heat of a small sun. It doesn't just cut, it vaporizes. 3 inches of high-yield naval armor, designed to deflect torpedoes, liquefies instantly. The sound is a deafening, electrical scream as the molecular bonds of the steel are ripped apart. Watch as the hull, which once held back the crushing weight of the ocean, is sliced into manageable 180-ton donuts. The Manitowoc 31,000, one of the largest crawler cranes on Earth, waits to lift these massive sections like toys. We are peeling back the skin of the Leviathan to expose its anatomy. Miles of copper cabling, decks of aluminum, and the piping of the propulsion system. This is not standard recycling. This is the dismantling of a superpower's legacy. Every cut must be precise, every spark calculated. Welcome to the graveyard of the gods. This is where the Titan dies. Visible from low Earth orbit, the Puget Sound Naval Shipyard is a sprawling industrial fortress carved into the coastline of the Pacific Northwest. Covering 179 acres of sovereign territory, this is not merely a workplace. It is a high-security citadel dedicated to the life cycle of nuclear power. 14,000 personnel swarm this facility daily, entering through checkpoints that rival the security of the Pentagon. They are the only workforce in the nation certified to dismantle a nuclear reactor vessel. From the air, the scale of the operation becomes terrifyingly clear. Dry Dock 6 is a concrete canyon, deep enough to swallow a skyscraper, holding back the freezing waters of the Sinclair Inlet with a single steel caisson gate. Surrounding the dock is a logistical empire worth billions. We see the historic green hammerhead crane, a relic of the Second World War, standing watch over the modern Manitowoc heavy lifters. To the west, the mothball fleet of decommissioned aircraft carriers rusts in the rain, a ghostly reminder of the relentless march of time and technology. But the true complexity lies in the infrastructure you cannot see from the fence line. A dedicated rail network snakes into the heart of the controlled industrial area, featuring specialized 12-axle reinforced cast cars. These are the hearses for the atomic age, waiting to carry the most dangerous components, the reactor compartments, on a one-way trip to the high desert. Every scrap of metal, every inch of copper wire, and every flake of paint must be accounted for. The inventory value here isn't measured in dollars, but in national security and environmental safety. This is a zero-failure environment. One mistake here doesn't just mean a fire, it means an international incident. In this facility, the Cold War is being disassembled piece by radioactive piece. A nuclear submarine is a floating city, packed with a density of engineering that rivals a spacecraft. Once the outer skin is peeled back, the dismantling process shifts from brute force to calculated separation. The interior is a labyrinth of materials, each requiring a specific method of destruction. We begin with the aluminum crew berths, the racks where 140 sailors slept in shifts for months at a time. Under the crushing force of the La Bounty shear, these lightweight frames crumple instantly, reducing 30 years of service to scrap aluminum in seconds. The variety of destruction is staggering. In the galley, stainless steel ovens built to feed a crew at the bottom of the ocean are snapped like twigs. In the engine room, miles of piping are harvested. The most prized catch is the cupronickel saltwater cooling lines, an alloy of copper and nickel designed to resist corrosion, now worth a fortune on the commodities market. We see the removal of heavy lead ballast bricks from the keel, a toxic task requiring hazmat suits and manual labor, proving that not everything can be done by machines. But the most symbolic moment is the destruction of the torpedo tubes. These 21-inch diameter bronze-lined steel barrels were the vessel's clenched fists, capable of launching Mark 48 torpedoes or Tomahawk cruise missiles. The hydraulic shears struggle against the composite strength of the tubes. The steel groans, the engine RPMs drop, and finally, with a gunshot crack, the weapon system is severed. We harvest the high-value bronze liners, stripping the submarine of its lethality. From the periscope shears to the sonar sphere, every sensor and system is stripped, sorted, and destroyed. This is the deconstruction of a superpower's nervous system. The true test of the shipyard's capability lies not in the volume of steel, but in the extreme engineering of specific components. We enter the Sherwood Forest, the nickname for the vertical bank of 24 Trident missile launch tubes. These are not simple pipes. They are concentric cylinders of reinforced steel and composite materials, designed to withstand the violent ignition of a ballistic missile. The hydraulic shears, normally unstoppable, meet their match here. The jaws clamp down, the engines scream, and the tracks lift off the ground. It is a battle of physics. Only with millions of pounds of force does the tube finally surrender, exploding in a cloud of rust and composite dust. Deeper in the hull, we encounter the propulsion shaft. This is a 26-inch diameter cylinder of solid, forged HY100 steel. It is too thick for shears and too hard for saws. The solution is the thermal lance, a pipe pumping pure oxygen that burns at 10,000 degrees Fahrenheit. It bores through the solid steel like a laser, creating a geyser of molten metal. But the ultimate challenge is the separation of the reactor compartment. This section cannot be shredded, it must be surgically removed intact. We use a diamond wire saw, a loop of cable studded with industrial diamonds, spinning at 60 miles per hour. It slices through the pressure hull, the structural frames, and the incredibly hard Inconel piping in a single, continuous cut. It takes days of grinding to sever the vessel. Once cut, the 1,600-ton reactor package is sealed with 2-inch thick steel bulkheads, turning it into a massive lead-line shipping cask. Standing in the gap between the severed hull sections, we see the submarine's spine broken. The heart has been removed, and the Leviathan is truly dead. Once the submarine has been sheared into unrecognizable shards, the chaos must be organized. We enter the separation facility, a deafening cathedral of industrial sorting where the vessel ceases to be a ship and becomes a flow of raw data. A river of shredded debris moves at 500 feet per minute along the conveyors. Above, massive drum magnets spin with invisible force, snatching ferrous steel shards from the belt while non-magnetic waste falls away. The physics of the eddy current separator are even more exotic, repelling non-ferrous aluminum fragments with powerful magnetic fields, forcing them to leap like popcorn into separate collection bins. This is not just sorting, it is purification. Optical sorters fire jets of air at millisecond intervals to eject rubber and plastic from the material stream, leaving behind clean metal. We see the wire granulators chewing through miles of electrical cabling, stripping the insulation and spitting out rice-sized grains of pure copper known as chops, achieving a purity of 99.9%. Handheld XRF analyzers gun the scrap with X-rays, instantly identifying the chemical signature of stainless steel alloys to ensure the buyer gets exactly what they paid for. From the hydraulic balers crushing aluminum siding into dense cubes to the dust collectors trapping hazardous particulates, every system is designed to squeeze the maximum value from the wreckage. Human pickers stand on the line, their eyes trained to spot heavy copper armatures that the machines might miss. It is a symphony of efficiency. What entered the yard as a chaotic tangle of destruction exits as organized, graded commodities, ready to feed the furnaces of the next industrial generation. Beyond the mountains of steel and aluminum lies the true treasure of the disassembly, the strategic and precious metals hidden within the submarine's nervous system. The main condenser unit alone is a massive lung of titanium and cupronickel, containing thousands of tubes that must be hydraulically extracted one by one. But the hunt goes deeper. In the exotics cage, we find zircaloy cladding and Monel 400 shafts, nickel-copper superalloys that are vital for national defense and trade for small fortunes on the commodities market. A simple spark test with a grinder reveals the identity of these metals. A dull orange spark confirms the high nickel content of Monel, distinguishing it from common steel. The electronics recycling lab is where the dismantling turns into mining. Cold War engineering prioritized performance over cost, meaning navigation and fire control systems are heavily plated in 24-karat gold to prevent corrosion. Technicians harvest circuit boards laden with thick gold pins and platinum contacts. From the backup power systems, we recover massive silver-zinc batteries, melted down into stackable silver bars that are returned to the Federal Reserve. Even the air scrubbers yield platinum group metals from their catalyst beds. We also recover hazardous but valuable materials like beryllium neutron reflectors and cobalt chromium stellite valve seats. These are not just scrapped, they are repatriated into the strategic stockpile. The sheer density of value is staggering. As we watch the London Metal Exchange prices fluctuate, the scrap from this single vessel represents millions of dollars in recovered assets. An armored truck departs the facility, loaded not with weapons but with crates of gold, silver, and platinum. The submarine has been transmuted from a war machine into a literal gold mine, funding the very cycle of its own replacement. The dismantling of a nuclear submarine is not a for-profit salvage operation. It is a rigid government program where the currency is accountability. The Ship Submarine Recycling Program, or SRP, operates under a unique economic model: cost avoidance. Every dollar generated from scrap sales is not profit, but a direct offset to the taxpayer's burden of disposal. The logistical heartbeat of this operation is the scale house. Here, massive dump trucks loaded with HY80 steel are weighed on certified Mettler Toledo scales. The difference between gross and tare weight determines the credit back to the Navy's ledger. But before a single ounce of metal can leave the controlled industrial area, it must survive the green tag process. This is the absolute bottleneck of the business. Radiological control technicians swarm every outbound load, using sensitive Ludlum detectors to frisk the scrap for any trace of contamination. A single click of the Geiger counter above background levels freezes the entire shipment. Only when the material is proven clean does it receive the coveted green tag and spray paint designation, granting it unconditional release to the public domain. Once cleared, the material enters a complex chain of custody. High-grade steel is auctioned via the General Services Administration, often bought by domestic foundries eager for the purity of pre-nuclear era steel. The logistics are military-grade. Barcodes track propulsion shafts from the boneyard to the rail car, ensuring that no classified technology vanishes into the black market. We see the final balance sheet: labor costs in the millions, hazardous waste fees in the thousands, balanced against the scrap value. The submarine enters as a weapon of war and leaves as a commodity, listed on a manifest, melted in a foundry, and reborn as civilian infrastructure. The shipyard operates on a circadian rhythm that is as relentless as the tides of the Puget Sound. At 0600 hours, before the sun has breached the Cascade Mountains, the dormant facility is jump-started by the arrival of 14,000 souls. This is the Green Army, named for the ubiquitous high-visibility vests that flood the turnstiles. In the span of a time-lapse heartbeat, the dry dock transforms from a silent concrete tomb into a hive of frenetic industrial activity. We see the massive portal cranes sliding along their rails like rooks on a chessboard, executing hundreds of lifts per shift with robotic precision. The visual compression of time reveals patterns invisible to the naked eye. We watch the scrap piles breathe, expanding rapidly as the excavators feed them, then collapsing instantly as rail cars are loaded and shunted away. The shadow of the submarine hull acts as a sundial, sweeping across the dry dock floor until the sudden, synchronized pause of the lunch whistle freezes the action. But the most critical movement is the water itself. Outside the caisson gate, the ocean rises and falls 12 feet with the tide, pressing millions of gallons of water against the steel barrier that protects the workers below. As the sun dips toward the Olympic Peninsula, the exodus begins. The parking lots empty in seconds, leaving behind a skeleton crew to man the dewatering pumps and ventilation systems. The sodium vapor lights flicker to life, casting the shipyard in an artificial amber glow. Under these lights, the submarine waits. In a single 12-hour cycle, 50 tons of steel have been removed, sorted, and shipped. It is a war of attrition, fought day after day, shift after shift. The facility may sleep, but the decay of the vessel is constant. Tomorrow, the Army returns to take another bite out of the giant. The destruction of a nuclear submarine is not just an act of disposal, it is a triumph of conservation. In a world of finite resources, the 18,000 tons of materials locked inside this hull represent a strategic reserve that must be harvested. By recovering 8,000 tons of HY-80 steel, the ship submarine recycling program prevents the excavation of 20,000 tons of iron ore and coal, reducing the energy demand of steel production by 74%. This is the massive hidden math of the scrapyard. Every pound of metal saved is a pound of earth left undisturbed. But the environmental victory is fought on the microscopic level. The hull was coated in paints laden with PCBs and heavy metals, toxins that could poison the Puget Sound for generations. We see the needle guns and vacuum shrouds capturing every flake of paint, ensuring zero ground contamination. Inside, the battle against asbestos is waged in negative pressure glove bags, filtering deadly fibers out of the air. The 400 tons of lead ballast are not buried, but smelted and reborn as new batteries, closing the loop on toxicity. Water, the lifeblood of the Pacific Northwest, is fiercely protected. Every drop of rain that falls into Dry Dock 6 is pumped through a blue forest of filtration tanks, scrubbing it of sediment and chemicals before it touches the Sound. The result is an industrial ecosystem where starfish cling to the pilings just yards from the cutting torches. Even the nuclear heart finds a responsible end. The reactor compartments, sealed for a millennium, rest in the high desert of Trench 94, isolated from the biosphere. We have taken a machine built for global destruction and dismantled it with a level of care that preserves the planet. The sword has not just been broken, it has been forged into a cleaner future.
God bless this submarine and all who sail on her.
Every ship has two lives, the one it lives on the ocean and the one it lives in the memories of its crew. For 30 years, this 18,000-ton Titan roamed the deep, a silent sentinel carrying the weight of global deterrence. Thousands of sailors walked these decks, slept in these racks, and trusted their lives to the integrity of this HY-80 steel. But all machines, no matter how mighty, eventually succumb to time. The launch day champagne has long since evaporated, replaced by the sparks of the plasma torch. The flags have been lowered and the hull numbers have been stripped away. The destruction we have witnessed is violent, yet necessary. We have watched the physical form of the vessel be erased, shredded, sheared, and melted down. The silent service leaves no trace behind. The propeller that churned the Atlantic is now dust. The missile tubes that held the power of the apocalypse are now scrap. But in this annihilation, there is a profound transformation. The steel that once fenced off the world in fear has been purified by the electric arc furnace. It has been poured into new forms, bridges, skyscrapers, and wind turbines. The sword has literally been beaten into a plowshare. All that remains of the submarine is the steel sail, mounted in a quiet memorial park, and the stories kept by the men who served aboard her. The dry dock stands empty, a concrete scar waiting for the next patient. The water of the Puget Sound washes against the caisson gate, indifferent to the history that was dismantled here. The mission is complete. The hazardous materials are contained, the strategic metals are reclaimed, and the classified secrets are destroyed. The giant has been laid to rest, not in a grave, but in the foundation of the future it helped to secure.